Hello everyone and welcome to another exciting installment of our online math classroom. What we're going to be talking about today is adding polynomials. And so hopefully by this point you are familiar with a couple keywords here. First one being polynomials. That is something you should know what it means because those are what we're adding today. And the second thing is like terms. So polynomials, if I were to give you an example, this right here is a polynomial. So poly meaning many, nomial referring to numbers or each of these terms in the middle here. Those are each of our numbers, each of our terms. We have many of them. That makes this whole thing a polynomial. Same with this whole thing right here. We have this term, we have this term, we have this term. So because we have many terms, many numbers, we call it a polynomial. Second thing is when I say like terms, what do I mean? And so that refers to this power of x right here. So I have -3, and that is stuck onto this x with a power of 2. Those are multiplying. So that means that this -3x squared, the whole thing, is a like term with this positive 8x squared. So when we talk about like terms, the key that we're looking for here is, do they have the same exponent and the same variable? So the next like term that you could pick out would be this -4x chunk. That has a like term over here, where there's positive 6x. Because technically, this is -4 times x to the power of 1, and positive 6 times x to the power of 1. So those also have the same exponent on x. Last like terms we can find would be this +2 and this -9. Those are our constant terms, and technically they do have the same power on x. It's just that the exponent is 0. So when we've got something like this, and I ask you to add these two polynomials together, what we're going to do is we are going to start writing symbolically. And so I've kind of already done this for you. What I mean by that is just write out each of the things that we're actually adding together. So don't worry too much about that right now. I've kind of done it for you in some of the later examples. We'll see where I haven't. Next thing is grouping like terms. So I already said these two are like terms. And then I said these two are like terms, and these two are like terms. But the problem with trying to group straight away is that I have a set of brackets right here, and when we're grouping, this is the operation that we're doing. We are adding. So if we think about this thing, before I can actually get to my adding, I need to make sure that I have done BEDMAS. And technically the exponents and division, multiplication as well. We're kind of going to get to skip over those for today. But for right now, just know that we have to do something with these brackets and with these brackets before I'm actually allowed to group like terms. So in previous units, you would have talked about what it means to distribute. So let's say that we had a 4 out front here. If that 4 is in front of your brackets, you would have had to take it and distribute it everywhere. And then you would have ended up with something that had been multiplied by 4 all the way through. So instead of -3x squared, you'd have -12x squared. Instead of -4x, you'd have -16x, and instead of +2, you'd have +8. So I just took everything and I multiplied it by 4. Except, in this question, that number 4 isn't actually written there. In this question, because there's nothing there, we get to assume that it's just a +1, which makes our life a whole lot easier, because if I distribute a +1, I get exactly the same thing. And distribute a +1, same thing, same thing. exact same thing is going to happen with this polynomial over here. There is technically a 1 that I need to distribute. But positive 1 multiplied by 8x squared, that's just 8x squared. And positive 1 times positive 6x is just 6x, and that's just minus 9. So now I've gotten rid of those brackets because I'm not worrying about the exponents, division, or multiplication right now. I get to actually go on to the adding part that I want to do. Except I haven't actually grouped my like terms yet. So before I start adding them, I'm just going to change the order that I've written this in. And what I mean by that is these two are like terms. So I'm going to actually write them together. And then I have these two are also like terms. And these two are also like terms. So I haven't actually changed anything going from here to here. The only thing that's different is the order that I've written it in. But like if you think of going 3 plus 2 or going 2 plus 3, well, those both equal 5 either way. So what I did to go from this to this is just change the order. Same thing going from here to here. All I've done is just change the order, still the exact same thing. Now I'm ready to move on to step 3, where I'm going to actually combine like terms. So in my black writing right here, I have negative 3 of something and positive 8 of that same thing. So it doesn't actually matter that this is x squared. Like a lot of people get thrown off looking at this and try to do all kinds of weird things with the x squared there. That could be a race truck for all we are concerned. Like race trucks aren't even really a thing. It would either be a race car or a dump truck, but this could be a race truck and we would be fine. Because all we're doing is we're saying, I have negative 3 of whatever this is, and now I'm going to add 8 of whatever that is. So if you have negative 3 and you add 8, you end up with 5 of that same thing. So it doesn't matter that that's x squared, just as long as it's the same in both places. Then I have negative 4 of just a regular x and positive 6 of a regular x. So when I want to combine these two, I'm not going to do anything funky with the x. Same thing, that x is just going to stay right there. The only reason why I have it is like that's the same thing as x squared. It makes these terms like terms, but if you have like negative 4 apples and then you add 6 apples, you wouldn't do anything weird about trying to change the apples. Same thing right here. Negative 4x's, positive 6x's, we are going to call that plus 2. And the last part, 2 minus 9, should be negative 7. So what we have done now, at this answer right here, is we have taken those two polynomials that we started with, we have added them together into a single polynomial. Now, I have all of this stuff pre-filled in. If you want to refer back to the PowerPoint afterwards, that's kind of what this is there for. But generally speaking, I'm not actually going to put these things up as I'm going. So I like to talk through like kind of the way that I did right here. And then this is just for like, if you need to go back to the PowerPoint afterwards, it's filled out for you just in case.